In this video, we are going to talk about deriving the radius of a Bohr model. Now, if you are new here, please take a second or two, then subscribe, like, and share the video. Now, when deriving the Bohr model's radius, we are going to relate two forces here. Now, the first force we are going to relate is the centripetal force and the Coulombic force. So we are going to equate these two forces. Now, the Coulombic force Fe is always given as K, which is proportionality constant, multiplied by Q squared, standing for charge, divided by radius squared, R squared. And then the centripetal force Fc is given as mv squared divided by R. Now, after writing like this, we are now going to equate these forces so that we have mv squared divided by r is equal to kq squared divided by r squared. Now, to remove this r here, we shall multiply here by r, then this side also by r, so that this r shall cancel out with that, remaining with mv squared equals to this r shall cancel out with 1r there. So we shall be left with kq squared divided by r. Now, this is a Bohr radius. Bohr radius deals with an atom. So the charge here should be the charge of an atom. And the charge of an atom Q is given as the atomic number of the atom, Z, multiplied by the charge of the electrons, E. Now, because the Q here is squared, so we are going to square the charge of the electron here. So we are going to have Q is equal to ZE squared. Now, instead of writing Q squared, we shall substitute it with this one. Now, so that we have mv squared equals to k ZE squared divided by r. Now, after writing it like this, you need to know from the de Broglie's equation, lambda is given by h divided by momentum, which is given as mv. Now, and this can also be written as mv equals to h divided by lambda. But lambda is given as the circumference. So mv equals to h divided by circumference is given by 2 pi r. Now, after writing it like this, we need to have v on this side. So we shall divide both sides by m. This side shall be divided by m, then this side also by m, so that we have v is equal to h divided by m, then 2 pi r. 2 pi r. After writing it like that, you need to know that h divided by 2 pi is always written as h cross. So these are special Planck's constant. So we are going to substitute, instead of writing h divided by 2 pi, we shall write it like this, so that we have v equals to h cross divided by mr. Now, after writing it like that, we need to substitute it now here. So instead of writing mv squared, we shall write, because this is v, so v squared is given as h squared divided by m squared r squared. So we are going to carry the whole of this and substitute it here. Instead of writing v squared, we shall write this. So the new equation becomes m multiplied by h cross squared divided by m squared r squared is equal to k then multiplied by z squared divided by r. Now, after writing it like this m shall cancel out with 1 m here, so we shall left with h squared divided by m multiplied by r squared equals to k ze squared divided by r. Now, this r can be removed, multiplied by r on both sides, so that this cancel out with that, then this r cancel out with 1r here, so that we have h cross squared divided by mr is equals to kze squared. Now, after arriving here, we need, our point of interest is r, so we need to make mr to be the subject of our formula. So we shall have mr is given as h cross squared divided by now k z e squared. After writing it like this, so we shall have to divide both sides by m, this side divide by m, this side divide by m, so that we arrive here. By dividing by m this side, we shall remain with r is equal to now h squared, h cross squared divided by kze squared multiplied by r, so that we have m kze squared. Now after writing it like that, now this r stands for the radius, the Bohr's radius is now given as h cross squared divided by k, which is the proportionality constant, multiplied by z, which is our atomic number, multiplied by the charge of the electron e squared, then multiplied by mass. Now this is the final formula of the Bohr's radius. Thank you for watching, guys.